Yo, what's going on, guys, and welcome back. Today we are doing Introduction to Antivirus. So this is actually one of my favorite boxes because this is one of my favorite things to do, not just in pen testing, red teaming, blue teaming, anything. It's just in general. I think it's super fun. I actually do this a lot. I have a lot of fun with it. I'll do some pretty out of the box stuff, and I think that's where you can get real creative in this. So let's go ahead and hop into it. If you guys are liking this content, if you guys like the Try Hack Me walkthroughs, hit that like button, hit that sub button, and let me know in the comments because I don't know what you guys like. I know that sounds silly because you'd think I would, but in reality, some of the videos that I upload that I think will do great do really poor, and then some of the ones I upload that I think are like they do great, and I'm like, what? So I actually have no idea what you guys like, and I'm realizing that more and more as I go. So let me know. And then also, if you guys hop in the Discord, we chat in there all the time, and we're doing some projects in there. So there's chances at giveaways and stuff like that. So hop in the Discord and let me know what you guys think. Let's go ahead and hop into it. So first off, welcome to Intro to AV or Antivirus. Here's the thing. Antivirus, it's going to talk about it here, and it talks about antivirus and EDRs, which is endpoint detection response. I'm trying to find where they actually talk about it. Here we go. So here's, in addition to AV software, other host-based security solutions provide real-time protection. Okay. Yes, there is a difference. There is a difference between a true antivirus and a true EDR. What I mean by that is antivirus is or reactive in a sense, right? So what I mean by that is antivirus is going to respond because it does a scan or because it detects something going on. An EDR will actually act on that. So what I mean by that is an EDR can quarantine the machine. It can do actual proactive steps where an antivirus, true antivirus, doesn't do that. It just detects it. So nowadays they're blended. There's a lot of antivirus and EDRs that are kind of all in one thing. So they explain the difference here, but in reality, when you hear someone say antivirus nowadays in a large scale environment, enterprise environment, most of the time there's going to be some EDR-esque tooling in there as well. It's not going to be simply just an antivirus. Now, some places do have them separate, so keep that in mind. But it is going to be kind of mingling with each other. So keep that in mind when we're talking about it. And you can see an antivirus application performs scanning, detecting, and removing of malicious files. That's about it. But on the other hand, EDR monitors various security checks in the target machine, meaning that an EDR can not just tell you if there's malware on the machine, but if someone's doing something they shouldn't. So that's where it's going to look at behaviors as well. So, and you can see file activities, memory, network connections, Windows registries, processes, etc. Whereas an antivirus is looking at files. So again, proactive, reactive, sort of. But nowadays they're pretty intermingled. So just keep that in mind. Okay, so I'm not going to read this to you guys. You guys can read this. But basically, the virus that infected John McAfee's PC was called Brain, and the first antivirus was basically designed to get rid of that virus on his machine. And that's when they kind of said, "Oh, bingo, we've got something here. Let's run with it." And most of you probably heard of McAfee at this point. So, which PC antivirus vendor implemented the first antivirus software on the market? And that was McAfee, and that's why. Antivirus software is a host-based security solution. So it sits on the host, which means on your computer, on the end user computer, etc. All right, so let's hop into the antivirus features. So an antivirus engine is responsible for finding and removing malicious code. We talked about that. That's what it does. It removes code. It looks for files. That's mainly the big thing. Here's some of the features it should have. Scanner, detection techniques, compression, archives, unpackers, and emulators. We're going to cover them. Scanner is exactly what it sounds like. It's going to scan your machine, and it's going to look for malicious files. This is something that you should be doing all the time, not just on your personal machine, but in enterprise environments. There should be scans running consistently. You should know when something malicious is now sitting on your machine. There's a reason for this. Now, I know a lot of people are probably thinking in their head, well, if it can detect them before it gets on the machine, what's the point of the scan, right? But the reality is there's multiple things to look for with the scan. Number one, your machine might not be updated, right? A lot of scanners now, especially antivirus scanners, will tell you, even though, because like I said, they're not just antivirus anymore. They're also EDRs. It will tell you, hey, you haven't patched your machine in 6 months. You need to patch it, or else you're going to have some issues, right? So that's one thing, like right there. That's a quick win. The other thing that the scanners are going to do is the scanners, or a lot of malware nowadays, sneaks in, and it's not just going to go, boom, you're infected, boom, let's go. It's going to be slow. It's going to be smart. It's going to be methodical. And what I mean by that is it's not going to just get on your machine and take over. What it's going to do is it's actually going to slowly open and start unpacking itself. And it may even wait for trigger events, which could take longer. So you need to be scanning constantly because your files might change, and you might have had that malicious file hidden on your machine for a while and not even known it. And then all of a sudden, boom, now it's malicious and the scanner picks it up. So that's why you need to be scanning a lot. Detection techniques. And by the way, scanning does eat up bandwidth. So don't just like, because I say scan a lot, don't just like have consistent scans running because you'll never get anything done. So an AV detection technique searches for and detects malicious files. Different detection techniques can be used within an AV engine. So they're signature-based, heuristic, and dynamic. Signature is exactly what it sounds like. Everyone knows what a hash is for a file. It looks for the hash of a file. That's its signature. Okay, if it has a database of a bunch of signatures that are known malicious. When one pops and it's got the same signature, boom, just get rid of it. There's no questions asked. It doesn't need to. You don't need to investigate. You don't need to. It knows it, right? And a hash is one time. It knows. But heuristic detection is more advanced. It's a little bit different. This can be a little bit more behavioral. So what that means is, for instance, it's not normal for Notepad to interact with LSAS, right? Notepad's not going to open up LSAS and start dumping hashes. That's not normal. That would never happen in a real environment. So it notices, hey, Notepad is interacting with LSAS, and now it's trying to dump hashes. That it's noticing a behavior that doesn't make sense, and that's heuristic. It's learning that behavior, and it's saying, get it out of here. That's not normal. So now dynamic detection. This is something else. This is a technique that includes monitoring the system's calls, APIs, and testing and analyzing an isolated environment. So you've probably heard of this without knowing it. It's sandbox, right? So it will run the malware in a sandbox and tell you what it does. If it's a legit program, it may be fine. But again, malware gets smarter the same as detection gets smarter. So while yes, you run it in a sandbox right now and it looks great and you're like, okay, I let it run. It's been 3 hours. Nothing's happened. It's just running the program, whatever, we're good. Some of those wait for trigger events. Some of them are delayed. Some of them may sit on your environment for a month before they actually trigger. Now, that is how they get smart, because they can, if you have a sandbox dynamic antivirus, it's literally just going to not see anything changing until it happens. So you should have some sort of approach with all three of these. You should have kind of a hybrid environment in that sense. All right, compressors and archives is exactly what it sounds like. You need a feature to be able to look at these zip files, compression files. The reason is, if I was evading your malware or your antivirus right now, and you had just a basic, old school antivirus, I can just compress the file, and your antivirus can't read it, and there you go. It's on your system. So that's why you need it to be able to decompress and scan through all the files before the person unzips it themselves. Okay, portable executable parsing and unpackers. This is exactly what it sounds like. Malware hides and packs its malicious code by compressing and encrypting within a payload. So if you don't know what a portable executable is, it's just a part of a Windows environment where you have these little codes, or they're little programs, that make up a bigger program. And so it's similar to like DLL files, where you have all these files. It's if you're familiar with a GitHub repository, it's very similar, right? You have all these files in a repository, and it's running them all in a certain sequence and things like that. That is what a portable executable is, part of that sequence. So large applications almost always have all of these smaller applications that run at the right time, or else the reality would be, if you just ran a large application without this sort of hierarchy structure and this directory structure, you would just have an application that eats up everything as far as resources go. So that's why they make them like that, because I don't need everything to run all at once, all my features of my application. I only need the features that you're selecting to run at that time. All right, so an emulator is an antivirus feature that does further analysis on suspicious files. So once an emulator receives a request, this is your dynamic, right? So once it receives a request, the emulator runs the suspected file, whatever, in a virtualized and controlled environment, a sandbox, okay? And it monitors what it does, and then it tells you what it does. And when it gets enough indicators, it doesn't need to keep running. Like, it's not going to be like, and the reason for this is because there are viruses, there is malware out there that can get out of a sandbox and escape, okay? So it doesn't need to wait until it can sit there and escape. It will just run. It says, okay, did this, that's enough for us. That's that's a virus. Let's get it out of here, okay? So other common features, self-protection driver to guard against malware attacking the actual AV. That's pretty self-explanatory. Firewall network inspection functionality. So again, this is where it's going a little bit beyond the typical antivirus. Command line and graphical interface tools. That's just a nice feature. Daemon service, management console. These are just nice features. Okay, so now which antivirus feature analyzes malware in a safe and isolated environment? That's the emulators. They do it in a safe sandbox environment. I'm not sure why they don't say sandbox in here. I don't know if it's not the proper term anymore. I don't know. An unpacker is a feature that is a process of restoring or decrypting the compressed executable files to the original. So that's what we talked about here is the unpackers. And then here we have just read the above. Okay. So now we deploy the VM. We did that. That's it right here. Okay. So now static detection. This is where we start, right? We start with static, then we go dynamic, then heuristic. So static detection is the simplest type of antivirus detection, but it's also one of the most useful. And the reason I say that is because there are millions of attacks a day, right? I'd say 95% of them, that's probably a generous estimate, are script kiddies or somebody that downloads something or somebody that doesn't know what they're doing or someone that does know what they're doing and they don't care. They don't want to put the time and effort in, spammers and stuff like that. They're just spraying and they're saying, we'll find somebody. And they will. They'll find somebody. They'll get something. This stops all of that. So it stops the noise and lets you focus on the actual attacks, the people that are targeting, okay? So that's one of the biggest things. That's why I think this is one of the most important. I know some people will say, well, it's not that important because it's so simple, right? Like people aren't going to use this exact piece of code, and yes, they do. And it's people that don't quite know what they're doing, but just want to get into anything. The script kiddies, that is the majority of attacks out there. The more advanced attacks are much less often and much more thought out. So there might be less often, but that's because they're doing quality over quantity. Okay, so now we're going to use the Clam antivirus. If you guys don't know what this is, let's see if it tells us a little bit more about it. Clam antivirus is pre-installed. It's just an antivirus. It's pretty simple to install. It's really nice. I believe it's open source, so you can just download it. And you can see here, so we're going to use the Icar test file. If you don't know what this is, it's an old test file. I think it came out in like 2003, like it's been around forever. All it is it's just got ASCII characters. It doesn't have any, it's not an actual virus, okay? But it has characters in it that should flag your antivirus. And the reason that's important is because it gives you a test file that isn't actually malicious that you can run and say, hey, is my antivirus going to catch this? And if it does, great. If it doesn't, might want to look into what's going on. Okay, so now backdoor 1 is a C# program that uses a well-known technique to establish a reverse connection. Okay, so they just have a backdoor 1, a backdoor 2, written in C. Antivirus check is a C program that enumerates. Okay, so basically these are all malware. Some of them are on the brink, right? Like the antivirus check, it enumerates antivirus software in a target machine. I don't think that, and it says right there, note that this file is not malicious. We'll discuss it more. That's not malware. It can be used against you, but it also can be used for good. So I don't consider that malware. And then notes.txt is just a file that contains a command line, and we'll show you why that's important. Okay, so now we have the clamscan.exe binary to check how it performs against the samples. I'm not going to run these because I did run them, and they take some time, so I'm not going to run them. So here you can see this is what it'll look like. You run it. You can see they ran C program files, clamscan, and they ran the clamscan against the samples, which are the ones they just covered above. And you can see, here's what you got for the results. You got the AV check was okay. The backdoor 1, that was found as malware. Then you have backdoor 2. That's okay, but that's weird because backdoor 2 they told us was malicious, so it didn't catch that. And then you can see here they found another one, and that's the ICR, the test file. So that's good. They found that one. And then notes was okay, so which we know isn't a malicious file, so that's good. So now you can see that you can run the debug file, so you can run it and then specify the file, and it'll tell you exactly why it found it or didn't find it, and what it checked. So you can see here we did the debug, and you can see, oh, this is for the ICR. Okay, so they did the debug for the ICR, and you can see that it gave them the signature. That's why it detected it, because of the signature. And the signature is the hash. So that signature is known malicious. Now, keep in mind that's a test file that's supposed to detect, right? So now you can see if you generate they're going to use sigtool.exe to generate the MD5 hash. And when they do that, they get the same hash, which validates what it said, right? So that's what they're doing. They're just validating. So now you can create your own signature database. So this is pretty cool, but this honestly would be insanely time consuming if you did this, unless you're a malware analyst. That's what some of them do. They add these into the databases. But if you were just doing this every day as part of your job, you would get very swamped very quickly as a SOC analyst or something like that. So you can see they're going to use the sig tool. They're going to get you can see here they use the sig tool. They get the MD5 hash for backdoor 2 because backdoor 2 did not get detected. And here's their detection, right? So you can see that there's the hash for it. And what they're going to do is they're actually going to put that, you see they do the same thing, but they put that into tryhackme.hdb, which is the database for the signature hash database, right? So as a result, file will be created in the current directory. So now when it runs, if you remember, it didn't find backdoor 2 before. Now when it runs, you can see it found backdoor 2 found, but you notice it says unofficial. That means someone added it manually. It wasn't something that was already there. So anything unofficial means that it's detecting on what you implemented, not what Clam implemented. It's not a huge distinction, but it's important to know because if you create custom rules and things like that, which we're going to cover here in a second, you want to know that your rules found it and not the Clam database because, number one, you may need to report it to Clam and have them upload it. So that's a big thing. So now Yara rules. So if you guys aren't familiar with Yara rules, there is a box on Yara. I think I might have done it on this channel. If not, let me know if you want to see it and I'll do it. But the Yara rules are very important because Yara rules are in a lot of programs. You can use Yara rules for a lot of different security tools. And so it's good to know how to write these rules and what to do. So that way you can implement these into a lot of tools, especially free open source tools use these. Not just open source, but I'm saying a lot of open source tools use these. So you can see Yara is a tool that allows malware engineers to classify and detect malware. Thanks. Yara is rules-based detection. So you can use Yara rules to actually not only find things with antivirus, but also to block things. So this is only going to cover how to find things, but it's important to know that you can use Yara rules if you properly implement them. And you can actually go to like some GitHub repositories and get lists of Yara rules that you should implement. And you can put them on your EDRs or your firewall, whatever tools you're going to use to block, and it will actually automatically detect certain things. So that's really nice. So you can see here, it's a pretty self-explanatory rule. It kind of, if you're familiar with JSON, it looks, I don't know what it's actually written in. It may be written in JSON. I don't know. But you can see it's pretty self-explanatory. It looks pretty much like JSON to me. And the only reason I say I don't know is I don't know what Yara's backbone is, if you will. So here we go. So rule, try hack me demo rule. They named it. That's what they named it. Demo rule. You can see they put meta. This is just the metadata, the author, the description. You can put whatever you want, but they wanted you to be able to see who the author is and what the description of the tool. Now you can see strings, and they use the variable A. This is the string they're looking for. C, users, try hack me, source, repos, AV check, Now, where did they get that? What you can see here is if you go to the AV check, they actually ran strings on it. If you don't know what strings is, it's one of the most useful malware analysis tools you'll ever find. And it sounds insane because it's the most simple tool you've ever seen. It literally just pulls out human readable characters. and that are strings. Okay. And so why is that? You might be thinking, okay, whatever, that doesn't sound that good. I can just open the file. Well, if you have an application with millions of lines of code and a lot of it is just gibberish because it's encoded or whatever, or it's compiled, however, if you do if you do strings on it, you may get snippets of strings that let you piece together what it's doing without having to decompile it and redo the whole thing. So it can save you a ton of time. Now, when they ran strings on AV check, which is the one we're trying to do, you can see they've got this. This is the repository or the directory that it's pointing towards. So what we're going to say is that's an indicator to us. That is an indicator of this malware. So, for instance, let's put this in a real scenario. Let's say you worked in healthcare, right? And you look up, so full circle, you look up the MITRE ATT&CK framework, and you see that in healthcare, there's an APT out there, and they use this specific malware, right? They use it all the time. You go and check your antivirus. The signature is not in there, but you put it in there, right? You still don't want to risk them just changing something in it and then that malware is still coming through. So what do? You look for indicators. You look for, hey, it's actually going to this, it goes to this directory every time. It looks for this directory every time. So now we can actually use Yara rules to say, hey, if you see a reference to this directory, mark that to us and tell us that it's a virus. Okay, so you can see A is your boom, and then the condition is if A. So here's what it's looking for, and if that condition exists, let us know it's found. So now when they run it, you can see they run the clam scan, they run it, and you can see now they actually get the first one, the AV check actually pops up, and it says unofficial, but it says, hey, yara.thm demo rule. So that's what found it, was the Yara rule. So you know, okay, now you notice here though, here's the problem. Notes.txt got flagged as well. That's not a malicious file, so that's a false positive. So what does that mean to us? That means, hey, we need to tweak our Yara rule because we don't want it to just pick up strings in files, because here's the reality. If you're in a large scale environment and you look for a specific string, and let's say that string is 10 characters long, right? It doesn't matter what it is. And you put a Yara rule in there for it, the chances of it finding other files that have those exact strings is not a whole lot, but there is that chance. So you want to be more granular, more specific. And you can see here what they're doing is they're saying, okay, notes.txt, I'm not worried about a text file because this is an executable. It's got to run for me to be, or for it to actually do anything. So what they do is they went and they looked at the binary. And if you aren't familiar, you can see that right here. Executables always start with the ASCII character MZ. That's huge. That means we can automatically tell you if it's a executable file, okay? Or 4D5A in hex. So you can do either one. And you can see here, they actually did MZ. So what they do, they went down to the Yara rule. They added MZ as another condition. So we need it to also have MZ. Now, here's the thing. You're thinking, well, there's going to be hundreds of files out there with MZ in it, right? Well, look how they did it. They said we need B, which is MZ. We need MZ to be at 0, meaning it has to be at the very beginning of the file. It has to start the file every time. That tells us right there, that rule is an executable. Now, and we need it to reference this directory. So now we're saying it has to start with MZ, and it has to have that directory in it. So that's huge. That tells us right there, boom, it's only going to detect that. So now when we run the Yara rule, you can see you got Yara, THM, demo rules, unofficial, found. It found the first one, but it did not flag the notes this time. That's big. That tells us right there that the Yara rule worked. And you do want to test out these Yara rules. I'll say that. Okay, so now what is the SIG tool output to generate an MD5 of avcheck.exe? And you can go up here and they literally did it for us. You can see, nope, not strings. Right here, you can see, we'll just say, we're in the clam AV, so we'll say sigtool.exe and, whoops, backdoor. Did they say backdoor? What did they say? The clam check? what did they say? AV check. Okay, so we're going to say sig tool MD5 because they want the MD5 hash. And they said AV check. So you just go up here and you look at it right there, MD5. And we wanted AV, I think it's capitals, AV check. Is that what it was? It's in the samples anyway. So we got to go see users. THM is the user. Desktop samples. And then the sample was clam. What was it? AV check. So it was just AV check. AV check.exe. And we hit enter. And you can see we get the hash right there. Now, it doesn't want just the hash, it wants the full output. So you want to put that full output here, the hash and the AV check. If you don't do the full, it won't give it to you. So now use the strings tool list to list all human readable strings of the AV check binary. So we basically do the exact same thing. I'm only going back because I don't want to type that whole thing out again. But we just go to strings and we hit enter. And you can see we get all of this information. Now, it's pretty simple to find the hash, or find the, and there's where they actually, that's the string that they looked for as an indicator. So you want to look for very unique indicators when doing these rules. And that is a very unique indicator, right? Not normal tools don't always reference a specific point like that. Now, it's pretty easy. You can see that the try hack me right there. I can't even tell that says strings. I know that. So anyway, you find it. That's pretty simple, right? But what you can do is you can actually go here, do the same thing, and then pipe it to find string. And we know that they're going to start with THM. We hit enter, and boom, there it is. So there's ways to just find it easier. But this is how malware analysts and things like that, and even SOC analysts, etc., this is how they write their own Yara rules. They look for indicators, right? Like this might be, let's just say, company name here. Let's say that was a very specific name. Like for instance, some APTs actually sign their malware. Not very common anymore because of this. But if they signed it, if they said, Mr. Robot in it every single time they put a malware in there, you can just say every executable with Mr. Robot in the file, get rid of it. I don't want it. And it will detect it for you. So now, other detections and techniques. This is dynamic detection. This is exactly what we talked about before. You got these files, you put them in a sandbox, and it'll tell you what goes on with it. This is a very good technique. There's static and there's heuristic, or static heuristic, excuse me. This is the process of decompiling and extracting the source code of the file. So what's this mean? This just means that you're taking out the compiled file and you're decompiling it and then reviewing the code just like you would with static analysis. Yeah, that's great. That's good. You should be doing that. But the dynamic is really the bread and butter here, the dynamic heuristic analysis. This is where you're actually looking for behaviors. Now you can actually manually do this, right? I could go through and look at behaviors and say, ooh, that's weird. Normal people shouldn't do that. And then reach out to the person that did it, right? If they work at the company and say, hey, why'd you do this? Or did you do this, right? Yeah, that you can do that. But then there's also machine learning heuristic. It's not truly machine learning, but what it's doing is it'll watch your environment. So this is very common in today's society or in today's environment, and it will watch all of your environment and every day to log what people are doing, understand what people are doing, and then it may alert you and say, hey, John never works past 6, and today he logged in at midnight. That's weird, right? That sounds like a very simple one, but that is a very good detector indicator of compromise because that is weird, right? John should never log in at midnight. And you may call John and say, hey, John, what's going on, man? I saw that you logged in at midnight. And he may say, whoa, no, I didn't. And then you start the investigation. Or he may say, yeah, I forgot one thing and I had to hurry up and get it put in there before I forgot. And you say, oh, okay, thanks, John. I appreciate it. And then you're done, right? So those are the type of things that you're looking for. It's obviously much more complex than that, but that is a very simple scenario that does happen and can happen. So you can see which detection method is used to analyze dynamic detection. So now AV testing and fingerprinting. We've talked about VirusTotal on this channel multiple times, but basically what is it? It is a tool that you upload what you think is malware, malicious URLs, hashes, etc., and it will check and tell you if it is. It will do a couple of different checks, but it does go through and actually run it in a sandbox as well and all that stuff. But keep in mind, VirusTotal, for as great as it is, it also shares those files. You can get a subscription to VirusTotal, and you can take the malicious files and download them if you want to analyze them, right? So it's a great tool. The problem is, guess who also has access to this tool? Attackers. So what's an attacker going to do? First thing he's going to do whenever he gets a new sort of malware that he's going to try on your network, upload to VirusTotal, because he knows what you're going to do. So you upload to VirusTotal and say, boom, and then it got detected, I'll change it, and then try it again. So he knows too. So keep that in mind. That's where it gets a little bit dicey. Now you can see here's some two alternatives to VirusTotal. Now fingerprinting AV software as a red teamer. So this is as a pen tester, as a red teamer, whatever. I need to know what antivirus is being put on these machines because I need to avoid it, right? I don't want to get caught. So here's some common antivirus names. This is the service name that's going to be running, and this is the process name. Now, why would I need to know that? Let's say I did hack onto your machine right now. Okay, and let's just go to Task Manager. And we'll go to, oops, I didn't mean to go to performance. And this thing's running out of its mind here. But anyway, we go to Task Manager and we look for these, right? If we found one of these, then we know, okay, so that's what it's running on it, right? That's kind of what their thought process is. Now, there's ways to do that a little bit more automated, but I'm just saying that's the whole thing behind it. Now, they have this Sharp EDR checker, and you can see it's a public tool. You can grab it, and it will do the same thing. It'll do it all automated for you. It'll just grab it and say, hey, we looked at, and you can see it, I think it tells you, but basically it's going to look at DLLs, it's going to look at services, tasks, it's going to look at processes, all that stuff, and say, hey, this is how a regular EDR works here. That's whatever this tool is, and it's followed that pattern. So this is the EDR that we believe is on there. So that's basically what you're doing. And then you have you can see they made their own. So coding our own program. This is a pretty self-explanatory program. You can look at it, and even if you don't read code, or know how to write code, you can probably read this and tell me exactly what's going on. Select from the Windows 32 processes, and we're looking for these specific executables. And if we find them, there we go. If not, you get services not found, or software is not found. So you can see, pretty self-explanatory, pretty easy. You can write your own. Now, here is where you got to be careful, because here's what they're saying here is they took that same code they just wrote, and it's a great tool, but when they upload to VirusTotal, 2 security vendors flagged it already as bad. How does that even happen, right? They just wrote the code, and those are automated checks. Now, why would a security vendor write it poorly or whatever? Honestly, in my opinion, it's because you're trying to detect what they're doing, right? They have their own reason, and you can see here it tells them checks whether the image specified in the process creation event doesn't refer to an exe, blah, blah. So that's the actual rule that happened, but and here they're saying that's a false positive. In my opinion, that is not a false positive. I would want to know that this tool does that, because I would want to know, hey, someone's on my machine and they are trying this. I would want to be able to take that and get it flagged in VirusTotal and do some more research. I wouldn't want this to be a 100% clean program. It's kind of like Nmap, right? Like Nmap is a very clean program. It's not bad. But if you don't know Nmap and you go run it in VirusTotal and it comes up clean, you're not going to go, oh, okay, let me investigate more on it. You're going to say, oh, we're good. And so it kind of goes off that living off the land binary thought process. This is probably a good thing that it got flagged, is what I'm saying, where they're saying it's not. So that's just neither here nor there. But so you can see here, it says write it in a different language and see if it gets flagged. And that's true. You might be able to write it in a Python or something and it doesn't get flagged. So now you see how attackers do it as well, right? They write a code, it gets flagged. They say, ooh, crap. How am I going to get around that? They try a couple things. Let me write it in Python instead. They write it in Python, they upload it, it doesn't flag it. They say, boom, I got something here, okay? So there you go. Now, recap. I'm not going to recap the whole room. You guys get it. If you guys have any questions, please hop in the Discord and let me know. We can cover all this stuff. Antivirus evasion is one of my favorite things to do because it's just so fun to play with, right? Let me see if I can not get blocked, right? I think there's a lot more steps to antivirus evasion than this. This is just introduction to antivirus. So the antivirus evasion is what's a lot of fun. Hopefully you guys like this content. Hopefully you guys enjoy it. And if you guys do want to see more antivirus evasion, let me know in the comments below and hop in the Discord and let's chat about it. We can work on some live stream or something like that. So let me know what you guys think. Hopefully you guys like the content. Hopefully you guys have a great day. Thanks.